If you want to understand fixed income or bond from basic to advanced in less than 30 minutes, then this is the video for you. This video is going to provide you a solid kickstart to help you grasp the concept of bonds or fixed income instrument with ease, a lot of ease. Whether you are a bond trader involved in bond valuation, working on risk analytics focused on valuation techniques, or appearing for some financial certification like CFA, then this video is tailored for you. It covers all the key concepts of bond valuation, offering valuable insight across different concepts of fixed income. While it's challenging, I understand that to cover every detail of bond valuation and analytics in a single session. But I believe this is one of the most comprehensive video you will find to help you understand the bond concept from basic to advanced in just one go. To understand fixed income instrument, fixed income or bond analytics, you should start understanding the basic of time value of money. Once you get well versed with the basic of time value of money, then you should jump into reading the bond documents and understand the bond characteristics and feature. And once you are able to understand the bond characteristics and feature, then with the help of these characteristics and feature, you can design your cash inflow. And once you are able to design the cash inflow of the bond, then you would be very easily be able to understand bond valuation, which is slightly difficult, but it depends upon and only upon two concepts. That is time value of money, TVM, and designing the cash inflow. And once you understood the bond valuation, you can just pull the same concept of bond valuation to design the price yield curve. And if you understood the shape, the structure, the curvature of price yield curve, then the best thing that you should jump directly into the concept of duration and convexity, which is complex and difficult concept to understand in just one session. And then slightly you should understand the concept like key rate duration, why it is important, what is credit risk, and why you should respect credit risk in bond valuation or bond analytics. With that, let's get started with the basic of TVM. Okay, the basic of time value of money. In time value of money, we only have two important concepts. One is compounding, another is discounting. Yes, I know a lot of people are pretty familiar with the concept of compounding, but sometimes struggle with the concept of discounting. Both the concepts are pretty straightforward. Compounding is about finding the future value and discounting is the reverse, finding the present value. So for example, if I ask that at t equal to 0 today, assume you have 100 rupees or $100 outstanding. So what would be the value of 100 after 1 year? Given the interest rate in the market, say assume 5%, you will do 100 into 1.05 or 100 plus 5% of 100. Whatever the maths you apply, at the end you will get 105. Similarly, if I reverse the question and ask that after 1 year you will receive $100. So what would be the value of 100 today itself, right? You would do 100 upon 1.05, correct? Similarly, instead of 1 year, if I try to make it slightly complicated and make it 2 years and ask the question that if I have 100 outstanding today and I want to know what would be the value of that 100 after 2 years, then what you will do? You will first compound that 100 to the first year and then again you compound 105 you receive at the end of 1 year to the second year. So compounding would look like 100 into 1.05 and then again it will become 100 into 1.05 raised to the power 2. Similarly, if I reverse the question, then the maths will reverse again, and if I ask the question that 100 outstanding after 2 years, then what would be the value of 100 today? You would first discount that 100 to the first year and then you will again discount that 100 upon 1.05 that you discounted to the first year, then you discount that to t equal to 0 and you will receive 100 upon 1.05 raised to the power 2, right? Now if you want to formulate it, then the formula for finding the future value would be whatever the present value you have, you compound it or multiply with 1 plus interest rate upon 100 raised to the power time, And if you reverse the formula for discounting, it is present value is equal to the future value discounted by 1 plus interest rate upon 100 raised to the power time. So these are the two functions that you can use for compounding or discounting as per your use case. So that is the concept of time value of money, TVM. Now, once you understood the concept of time value of money, then we have to deep dive into how to read the bond documents and start fetching the most important bond characteristics from these documents. And with the help of these bond characteristics, you have to design cash inflow on the timeline, and that is critical. So we have taken handful of examples, exactly 3 examples, to understand it in detail, and we'll try to understand with the help of these bond characteristics, and that definitely will help you to fetch the requisite information from the bond prospectus or bond indenture. We'll understand how to plot cash inflow for the bond on the timeline. In the first example, maturity is given as 5 years, coupon is 10%, face value is $1,000 and frequency is annual. So for the first example, first of all, what is straightforward is to make the timeline. You can see that the maturity is given as 5 years. So make the timeline for 5 years. So it would be 1, 2, 3, 4, 5, as simple as that. And then you should look at what is the face value provided. And as you can see that the face value provided is $1,000, which you will always receive at maturity. So write down 1,000 at the end of 5 years. Face value is something that you always receive at the maturity of the bond. Then look for coupon. Coupon is something which is directly related to the face value, which you can see here. So coupon for the first example is given as 10%, but 10% of what? 10% of face value. So 10% of 1,000 would be 100. So 100 you will receive net every year. But the frequency tells you if you receive it in one bullet payment or in parts. As the frequency is annual, it means that you will receive the coupon in one payment, and that at the end of every year, which simply means that every year at the end you will receive 100. So you'll receive 100, 100, 100, 100 and 100, right? Now let's take the second example that you see on the screen. The maturity is again 5 years. So you start plotting the timeline for 5 years. That would be recommended, and jump directly to the face value, that is 100. You have to put down the face value at the end, which is maturity. Then look at the coupon the way we did in example number 1. 8% of the face value, and the face value is 100, which is 8 itself. Again, the frequency is annual, which means that at the end of each year you will receive 8. So at the end of each year you will receive 8, 8, 8, 8 and 8. And definitely at the maturity you would be receiving 100. Now if you look into the third example, the maturity is 3 years, so definitely you will not be making the timeline of 5 years, but 3 years. Then again you will write the face value, which is 1,000, so write directly 1,000. Coupon is 10% of 1,000, which is 100. That would be straightforward. But see, coupon is related. It is related to annual cash inflow, but frequency is something which determine whether you will receive it in one go or it has to be divided it into the whole year. So if you see the frequency that is given here, which is semi-annual, so you will not receive 100 once, but it would be divided into semi-annual cash inflows. So you'll receive 50 and then 50. So 50 and 50 every 6 months, but in net you will receive 100. So first you will receive 50, then 50, then 50, then 50, and at the end you will receive at the maturity 1050. Now for you, I will provide one example. Pause the video and try to solve it. So the maturity is say 2 year, coupon is 4%, face value is 500, frequency is quarterly, and just understand the trick part here is the quarterly frequency of the coupon. So 4% of 500 is what? 20, but because it is quarterly, you will receive 20 in parts every quarter. So you'll divide this 20 by 4, so end of every quarter. So at the end of every quarter, you will receive 5, 5, 5 and 5, but in net you will receive 20. Okay, so this was a basic discussion that we did on how to read the bond characteristics and how you will convert this information of face value, coupon, maturity and frequency into cash inflow on the timeline. Now, once you understood how to read bond characteristics, how to convert it into cash inflow, we will now understand the next topic, that is bond valuation. Now, for the bond valuation, there are two things which is important and critical. One is time value of money and another is cash inflow design. And in the time value of money, we have to be aware of the concept of discounting, which we already did, right? So I'll pull it there, and then we need to design the cash inflow. So we'll take the cash inflow and put it there. Okay, now because you have understood the time value of money and you have understood the design of cash inflow on the timeline, we will try to understand the bond valuation. We'll take the first example to understand the bond valuation with actual math. What is bond valuation? First, understand what is bond valuation. To understand bond valuation, the first thing I would recommend is not to treat any bond or fixed income instrument as liability, but it is an asset. So treat it as an asset. So in bond valuation, you're trying to answer the question like, if you're going to buy this asset today, which will give you 100, 100, 100, 100, 100 as coupon for 5 years and 1000 at the end of 5 years, then if you have to buy this asset today at t equal to 0, how much you are ready to pay, right? And that is the value that you're ready to pay today. And that is the price that you're ready to pay today. That is the value that you're ready to pay today. And that is called as valuation of any asset. What is the value? What is the price? What is the amount that you're ready to pay today to buy the bond, to buy the asset? And that's the concept of valuation. So to answer the question, or the answer to this question is very simple. It is the sum of present value of the future cash inflow discounted at the required rate of return. What does it mean? So for the time being, assume there is no interest rate in the market. There is no opportunity cost in the market. There is no inflation in the market. And if there is any asset which will give you 100, 100, 100, 100 for 5 years and at the end it will give you 1000, at maturity, how much you would be ready to pay today? Now the answer to this question is very intuitive, 1500. But the problem is that there is inflation. We assumed in this question that there is no inflation, no opportunity cost, no interest rate. But because there is interest rate, but because there is inflation, we have to apply the concept of discounting. So what you will do? You will discount the first 100, the second, the third, the fourth cash inflow and 1100 at the last at t equal to 0. And assume that the interest rate that which we have in the market is say 5%. And we'll apply the same concept of discounting here, that will discount the future value with the interest rate, and the formula will apply to find the present value would be the present value is equal to future value divided by 1 plus interest rate upon 100 raised to the power time, which we discussed earlier. So first we'll discount the first 100. Now time is 1 here, so the formula would be 100 upon 1.05 raised to the power time. For second 100, because the time is 2, it will be 1.05 raised to the power 2. For third, it will become 100 upon 1.05 raised to the power 3. For fourth, it will be 100 upon 1.05 raised to the power 4. For fifth, it will be 1100 upon 1.05 raised to the power 5. And the discounted value would come as 95.25, 90.70, 86.38, 82.27, 861.87, and if you sum all these values at the end, you will get the value of the asset, which would be somewhere around 1216. Similarly, you have to apply the same logic of discounting to all the cash inflow for all other example that you did. So in the second example, you again discount all 888 and 108. In the third example, you will discount 50, 50, 50, 50 and so forth, and 1050. And at the end, you will sum all the discounted cash inflow and get the bond value. So we understood bond valuation. It is simple and straightforward. Now, as you got familiar with the concept of valuation, we'll apply it to understand the shape of price yield curve, right? See, one thing, you should be understanding that the price yield curve means that how the price value or the present value of the bond is impacted with the interest rate. So when we were doing valuation, we had written that the price of the bond or the value of the bond or the present value of the bond is equal to cash inflow of the first year divided by 1 plus interest rate, cash inflow of the second year divided by 1 plus interest rate raised to the power 2, cash inflow 3 divided by 1 plus interest rate raised to the power 3, and so on and so forth. And the last cash inflow divided by 1 plus interest rate raised to the power time. So you can write that value, the price of any asset or the price of the bond, is a summation of cash inflow discounted by the interest rate. Now the question is, if I plot the price yield curve, when I say the price, that is the value of the bond, and yield is nothing but that is interest rate, and I want to know if I plot the price on the y-axis and yield on the x-axis, then is it going to be a downward sloping straight line, or is it going to be an upward sloping straight line, or is it going to be a downward curve, or is it going to be a downward sloping concave curve, or is it going to be increasing convex curve, or is it an increasing concave curve? How to find which graph is correct? There are two approaches to find the correct graph. One is the approach of differentiation or calculus. So you can start writing with a very basic equation which says that the price is equal to cash inflow upon 1 plus interest rate cash inflow 2 upon 1 plus interest rate raised to the power 2, so on and so forth, right? That's what we did earlier. So you can do a basic differentiation here to find out the slope, okay? So any mathematician would understand that why we are trying to find out the differentiation, because the differentiation will tell the slope of the graph. So when you differentiate the price with respect to the interest rate, it will come as minus 1 into cash inflow upon 1 plus interest rate raised to the power 2. Then minus 2 into cash inflow upon 1 plus interest rate raised to the power 3. Then minus 3 into cash inflow upon 1 plus interest rate raised to the power 4. So and so forth. If you look carefully, then the cash inflow is going to be positive, 1 plus interest rate is going to be positive, and if you look again, then all the coefficient of the cash inflow upon 1 plus interest rate raised to the power is negative. So the whole differentiation of the price with respect to the yield is negative, which also means that the slope is negative. So we understood that it is going to be a decreasing graph because the slope is negative. Okay, there is another way to look at it. It means that if the interest rate rises, the price will always fall, which you can also see from the equation directly, that the price is equal to cash inflow upon 1 plus interest rate. So if interest rate will rise, the price will fall. So definitely there would be some kind of an inverse relationship. So there are only three possibilities here from which you can choose, as we have three graphs which are decreasing, but exactly which one? And if you ever did the concept of graph, if you do double derivative, which is the rate of change of slope, and you try to find out the rate of change of slope, if it is coming as positive, then it is going to be what? A convex graph. It is negative, then it is a concave graph. And if it comes to 0, then it would be a straight line, right? So if you do take a differentiation again of the slope, which is d square p upon di square, then you will find the derivative as plus 2 upon cash inflow upon 1 plus interest rate raised to the power 3 plus 6 upon cash inflow 1 plus interest rate raised to the power 4, so and so forth. It means that if you assume that the cash flows are positive, interest rate is also positive, then your double derivative is coming as positive. So the rate of change of slope is coming as positive, which means that it is going to be a convex graph. There is another interpretation of this, which means that graph is decreasing at a decreasing rate, and it is only fulfilled by one of the graph, which is convex, where the slope is changing but it is decreasing. So the curve is decreasing at a decreasing rate. So this is our graph. So you understood the price yield curve is going to be a convex graph. Okay. So it is a convex graph. Now this is a very important concept because this is one of the approach through which we found the shape or the structure of the graph, that is differentiation or calculus. There is another simpler approach that you can take, which is directly using the concept of valuation. Now when I say interest rate is 5%, right? You found that the value of bond to be 1216.45 or 1216 something. Okay, let's plot it. Now what you have to do is to change the interest rate and find the value of the bond. That's it. So now you will increase the interest rate to 6% to 7%, find the value of the bond, or you will decrease the interest rate to 3%, 4%, you will find the value of the bond and you plot it. You plot these pointers. You can also change the interest rate to 5.01% or 4.99%. It is up to you. And start plotting it. As you plot it, you will find that it is going to be a convex curve, which you can easily do through Excel or Python, right? Which we do generally on our live sessions. And if you want to be the part of the fixed income live session, chat in the comment. So there are the two approaches through which you can see that the price yield curve of a fixed income instrument, right, is what? It is going to be a convex graph. And here we are talking about a simple plain vanilla bond, not talking about any optionality like callable or puttable feature. Whatever kind of bond it is, whatever maturity it is, whatever coupon it is, whatever face value it is, whatever frequency it has, it is going to be a convex graph if it doesn't have any optionality. Again, we discuss these optionality and higher concept only in the live sessions. With that, we have completed the concept of price yield curve and we understood the two approaches. And once through the approach of differentiation, which is completely mathematical in nature, and with the another approach, which was numerical, where we are trying to find out the value of the bond for different interest rate. The next concept that we have to understand is the concept of duration and convexity. Why we are talking about duration and convexity? Because we already discussed about duration and convexity. How? The slope of the price yield curve is nothing, is called as duration. And the convex nature of the price yield curve is what? Convexity. When we plotted the price yield curve, that was convex. And that is a very important feature of the price yield curve because the bond buyer loves convexity. Why? Let's understand why a bond buyer, a bond investor loves convexity. When we value the bond at 5%, the value of the bond was coming as 1216.45. And assume interest rate rises or fall by 1%. And definitely the bond price will change. When you recalculate the bond value at say 6%, increasing the interest rate by 1%, then it will come as 1168.49. When you calculate the bond price again at 4%, decreasing the interest rate by 1%, it will come as 1267.10. Now observe carefully that the rise in the bond price is higher than the fall for the same change in interest rate. Rise is 50.65 and fall is 47.96. So the rise is greater than fall in bond for the same change in interest rate. And that you will love as an investor when your asset prices will rise more than the fall. Other than convexity, we should also focus on duration. So duration has multiple interpretation. The one is the sensitivity. The second, it is the slope of the price yield curve. And the third, it is the average waiting time for the cash flows. Yes, it is a very difficult concept to be discussed in this session, but understand when we are doing the differentiation of the price yield curve or the price with respect to interest rate, that is dp upon di, that was the slope of the price yield curve and that is the duration. It is also the sensitivity because it was telling you that if interest rate changes by a very small amount, then the price will change by the slope right? So duration is also the sensitivity. And the last interpretation is it is the average waiting time for the cash inflow. So if you have a zero coupon bond with some X maturity, then the duration would be X, right? However, this is a very difficult concept to be discussed in a session like this. If you are interested in having a very detailed discussion about the duration, key rate duration and convexity, then we can have another session. Thank you. Have a nice day.